Hello everyone, today we're going to be talking about the absolute value function. And here is what the absolute value function looks like. I'm on Desmos right now, and so if I graph the absolute value function, it looks like this. F of x is equal to the absolute value of x. It has this V shape, and I'll tell you why it has this V shape. Well, what the absolute value function does is if you input a positive number, it doesn't do anything to that number. It keeps it the same. Like, for example, if you input the number like 6, your output's also going to be 6. If you input the number 3, your output's also going to be 3. If you input a negative number, your output is going to be the same number, but that number is going to be positive. So, for example, if you input -4, the output's going to be 4. If you input -8, the output's going to be 8. So we're going to focus on how to graph these absolute value functions, starting with an example. So we're going to graph the function the absolute value of x plus 3 using a table of values. Now you can actually graph any function out there in existence by using a table of values. And that's what we're going to do here. We're going to use a table of values. So with these x values, we're going to see what our outputs are going to be. So for these inputs, let's see what our outputs are going to be. G of -2 is going to be 5 because the absolute value of -2 is 2, and then 2 plus 3 is 5. G of -1 is going to be 4 because the absolute value of -1 is 1. 1 plus 3 is 4. G of 0 is 3 because the absolute value of 0 is 0. 0 plus 3 is 3. G of 1 is going to be 4 because the absolute value of 1 is 1. 1 plus 3 is 4. And G of 2 is going to be 5 because the absolute value of 2 is 2. 2 plus 3 is 5. And so you plot these on the coordinate grid, and then you kind of connect the dots. And so it looks like this. All of your absolute value functions are going to have that V shape. Another way you could do this is you can also recognize that the absolute value of x plus 3, that's pretty similar to the absolute value of just x. However, you're adding 3 to it. And so you can actually use transformations to see how this graph or how this function is going to be different than our original function, our parent function. Well, instead of the absolute value of x, it's the absolute value of x plus 3. So that transformation is going to be up 3 units. You take your original function, your parent function, and it goes up 3 units. It's translated up 3 units. And so this idea of applying transformations to our original function is going to be something that we're going to do a little bit later on. But for now, we're just going to plot points. So with this function, we're going to plot these points. So with these x values, with these inputs, let's go ahead and see what our outputs are going to be. M of 0 is 2 because, M of 0 is 2 because the absolute value of 0 minus 2 is the absolute value of -2, which is 2. M of 1 is 1 because the absolute value of 1 minus 2 is the absolute value of -1, which is 1. M of 2 is 0. M of 3 is 1, and then M of 4 is 2. And so once again, you plot these ordered pairs onto the coordinate grid, and then you kind of connect the dots, and it looks like this. We can also recognize that this function is a transformation to the right 2 units, because instead of it being f of x, or instead of our input being x, our input's now x minus 2. So if I input x minus 2 instead of x, it's going to be a translation to the right 2 units. All right, so that is how you plot points to create graphs of functions. We're going to do the same thing here. We're going to make a table of values. So we're going to find our outputs for these 5 inputs. So P of -2 is -1, because the absolute value of -2 is 2. 2 times -1/2 is -1. So make sure you have your order of operations correct. You have to do the absolute value stuff first before you multiply by -1/2. P of -1 is -1/2, because the absolute value of -1 is 1. 1 times -1/2 is -1/2. P of 0 is 0, because absolute value of 0 is 0. 0 times -1/2 is 0. P of 1 is -1/2, and P of 2 is -1. So you go ahead and plot these points onto the coordinate grid. You connect the dots, and that is your graph. Now we're going to go over this final example, which I think is probably the most important example out of all of them. Instead of plotting points, we are going to focus on using the different transformations to construct the graph. And here's what I mean. We're going to take our original function, our original f of x is equal to the absolute value of x function, and we're going to apply different transformations to get a different function. Okay. So here's what we're going to do. Instead of the absolute value of x, we're going to write the absolute value of x minus, what was it? -1. Now, what is this going to do to the graph? Well, instead of x, if we're replacing x with x minus 1, it should be a translation to the right 1 unit. And as you can see, that is definitely the case. Again, we're applying transformation of functions to our original function. So it's a translation to the right 1 unit. We're now going to multiply this function by 2. I know it says -2, but we'll multiply it by 2 for now. And this is going to be a vertical stretch by a factor of 2, because we're taking our function, multiplying it by 2, therefore it's a vertical stretch by a factor of 2. What happens if we multiply this function by -1? It's going to reflect across the x-axis. And now our final step is to add 3. So what is adding 3 going to do to this function? Well, it's going to shift our function up 3 units. It's going to translate our function up 3 units. So that is how you apply these different transformations to the original function to be able to get this graph. So like it says here, first you translate right 1 unit, stretch by a factor of 2, which we did, reflect, which we did, and then move it upwards, or translate the graph vertically upwards 3 units to get the graph here. Oh, I guess you can also make a table of values. If you're confused by all these transformations, you can also make a table of value. All right. Yeah, I think that's pretty much it. Actually, what I'm going to do now is I'm going to actually show you the vertex form of the absolute value function. So instead of just the absolute value of x, it's going to be the absolute value of x minus h. I'm going to put an a in front of this. I'm going to add k to this. And yeah, this is what we call the vertex form of a vertex. The vertex being the point h comma k. Now the vertex just means like the middle point, or like either the lowest or highest point of your absolute value function. And so what's cool about Desmos is you can actually see how changing all these different values, the h, the a, and the k, how they affect the graph. So if I increase h, it's going to shift my function to the right. Similarly, if I decrease h, it's going to shift it to the left. If I increase a, it's going to increase the vertical shift of my function. And if I increase k, that's going to move my function upwards. So yeah, this is what we call the vertex form of an absolute value function. So yeah, that is the video on absolute value functions.